All right. And after that comes the people who make the Agribusiness and Countryside Development Foundation possible. To our special partner institutions, senior special partner institutions, corporate members, and individual members, we thank you all very much for your kind generosity and support for the Agribusiness and Countryside Development Foundation. In partnership with the Management Association of the Philippines, we are a nonprofit member-supported foundation devoted to agricultural education opportunities for the goal of poverty alleviation through job creation. If you are joining us this morning, welcome. It's nice to see everyone here bright and early at 8 o'clock Philippine times, although our speaker, Mr. Roland Backhaus, are you in the Philippines right now or are you calling in from somewhere else?
Yeah, I'm in Washington, D.C. today, but I look forward to my next trip back to Manila.
All right. So it's 8 in the evening for you. Okay, thanks very much for joining us so late in the evening.
Happy to do it.
But yeah, if you're joining us today, good good evening or good evening, depending on where you are. If you are joining us 2 weeks later through our social media uploads, thank you very much for being with us, and we hope that today's session will be an educational one for you. It's a very interesting topic to have. So as I mentioned, the Agribusiness and Countryside Development Foundation is in partnership with the Management Association of the Philippines, and we are a support nonprofit organization. If you are joining us 2 weeks later, we'd like you to consider joining us as a member. It is through your generosity and support that we're able to keep bringing you what we do every week. If this interests you at all, or if you'd like to gain access to our wide network of agribusiness and countryside development professionals and organizations, do consider joining us as a member. Our links are in the description. You can send us an email, introduce yourself, and we'd be very happy to have you on. Okay, so we have a very interesting topic this morning. I'm really sorry to our membership for being gone for 3 weeks. I had set up an agricultural extension training and development program for my own company 3 weeks ago, and then after that I was in the north of the country with small farmers for small farm mechanization opportunities. So thanks very much for your patience. I'm sure our other members and our other trustees who had hosted our previous sessions have done very well. And I look forward to me personally seeing these sessions uploaded so I can give them a watch as well. Anyway, without further ado, I'd like to ask our chairman, Mr. Ernie Ordonez, to introduce our speaker for this morning. Ernie, please, you have the floor.
Thank you. That's why we like you, because you not only know agribusiness, you deal with small farmers and help them improve their lives. And I think that improving lives is characteristic of Roland Backhaus, who's our guest today. Roland, as you may have seen in our invitational letter, is the Executive Vice President for Global Strategy, the World Strategy, for Ultra Safe Nuclear Corporation. He has quite an impressive background. He went to the US Naval Academy, which everybody likes to go to, but hard to get into. Then he has a master's and then a law degree from University of Pennsylvania. And in the description, you see that he'll be talking about things very important to us because we need technology to propel ourselves. And that's why we like our president in this technology in pursuit of sustainability and helping small farmers and fishfolk, which is the objective given to us by our departed chair, Ramon, but of course by Bernie, whom we're very grateful for in getting Roland. Roland, basically, your background is quite impressive. Other than your fantastic schooling, you're right now a nuclear engineer and have broken lots of barriers in terms of nuclear aspects. You're even an officer of the US Florida nuclear-powered ballistic missile submarine. We want to let you also know that we Filipinos are very grateful to the United States for backing us at West Philippine Sea, where you have really helped us. You also helped us greatly in our moves for democracy, where we actually started a people power revolution that's copied around the world, and we have that democracy now. So we have special thanks for your country, who has been our ally for years. And today you're helping us not with restoring democracy, but in a sense, you're giving us economic democracy, because through your technology, our poor people can shape up and compete, and actually be more competitive in the global world, which you're an expert at. Roland, we'd like to ask you, if possible, for the first 5 or 10 minutes, tell us how you got into this particular area, and what connection it has to agribusiness. We want to have a personal connection with all our speakers. So for 5 to 10 minutes, they tell us about our lives. Because what we do is we contact people after the forum. And our objective, as our departed chair says, is not just to transfer technology. It's actually to do what our group's title is, countryside development, and with special emphasis on uplifting the poor. So we'd like you to talk to us a bit about that. And then after that, after your talk, you're from far away, you've come to the Philippines, we look forward to your coming again. You're a true friend coming to us. How we can help you. I mean, how we can help your mission. For example, we're a group of businessmen, so while we like to learn, we want to really spread the good news that our technology people come here with. Sometimes you connect them to banks or government agencies or other businessmen, so that we can spread the good news that we get through this technology forum. So we measure ourselves not in terms of actually just transmitting good knowledge, but possibly using that knowledge to really affect people's lives, whether giving them loans or connecting them to groups that don't listen to them, etc. So on that note, Roland, first 5 to 10 minutes about yourself. Second, how you think we can help you. And perhaps towards the end, you can give us a contact number, office number, etc. Because thanks to our young board, our board used to be everyone over 65. Now 80% would be below 45. And we're now have an audience of I believe 600 separate people. We used to have 35 people face to face, but now we're worldwide. So we'd like you to give us a bit background of yourself, 5 to 10 minutes. B, give us your idea of how we can help propel this fantastic technology you have. And at the end, perhaps give us a contact number, whether it's an office number or a personal number, so people around the world can call you. On that note, Roland, thank you for coming. I myself have a beneficiary of your country, because when I was fighting for democracy, I used to go to the Senate. I was in Washington, D.C., etc. And your country helped me avoid persecution. And at the first moment that we could get, we came back to help our country. So Roland, please take it away. The floor is now yours.
So thank you for that kind introduction and for the warm words. I certainly appreciate the opportunity to talk with this august group today. I look forward to talking with many of you, either individually or in groups afterward, as you might find helpful. I have very strong familial ties to the Philippines. Indeed, my grandfather fought in World War II in the Pacific and spent some very excellent time, he has told me, over the years in the Philippines, both before MacArthur's departure and after MacArthur's return. And he has had nothing but wonderful things to say over the past 45 years, during which I've gotten to talk with him about the Philippines and Filipino people. So I look forward to continuing that relationship between my family and the Philippines going forward. So thanks again for the kind invitation. I'm not sure that I can talk about myself for 5 minutes, but maybe 1 minute. I grew up just north of Washington, D.C., in a family which owned a small farm. And we operated that farm as a family, and we leased out that land to other farmers to sow and to harvest crops on portions of the farm that we could not grow. You know, we didn't have a lot of the large machinery that was required to grow alfalfa or soy, for example. So I grew up operating a small family-owned farm. In 1997, I started as a midshipman at the U.S. Naval Academy. And I remember the first day where I woke up at the Naval Academy. I got to sleep in until 6:30 in the morning. And that was terrible, I think, for many of my classmates, but it was wonderful for me because I knew that if I was home on the farm, I would have had been up for 2 hours, would have done a large bit of work, and would be just coming in for breakfast at that time. So that had two practical effects on me. One, it caused me to not want to fail out of the Naval Academy because I would have to go home and do that again and face my father. And two, it gave me, essentially 2 hours of extra sleep every single day, because I knew if I was home, I would have been up at 4 or 4:30 working. And I felt very fortunate to sleep in until 6 or 6:30 as a midshipman at the Naval Academy. As it happens, I did well enough in my academics at the Naval Academy. I have an undergraduate degree in nuclear engineering and English from the Naval Academy. I think I'm the first person to have done that. It's happened a couple times since, but I think I'm the first. I did well enough to qualify for graduate school, and I studied English literature during graduate school, and then also nuclear engineering. So I have both a master's degree in nuclear engineering and also in English literature. I was accepted into the submarine program out of the Naval Academy and spent a year and a half training to be a nuclear plant operator on Admiral Rickover's pressurized water reactor nuclear submarines, and thereby got some excellent experience, not only operating high technology and operating plants, but also as a leader of young men on submarines. I was fortunate enough to do that for 3 years as a junior officer on board the USS Florida, during which time I served as the reactor control assistant, operating and responding to the reactor and reactor support electronics, and also as the assistant chief engineer on a couple of different occasions when my boss was fired. I didn't make any extra money. I just got extra responsibility during those years. So that wasn't excellent, but I learned a lot during it. On my way out of the Navy, I taught both nuclear engineering and English at the Naval Academy as a professor. And then I started law school in 2008, 2007, and graduated in 2010 with a degree from the University of Pennsylvania. Since that time, I've been a practicing nuclear energy regulatory lawyer and transactional lawyer, which means that I have done sales of nuclear reactors around the world and in the United States. I have a strong background in nuclear energy law and regulation. Indeed, I helped set up the nuclear regulator and the full nuclear industry in the United Arab Emirates between 2009 and 2011. In 2011, my family and I moved to Riyadh, Saudi Arabia, where we advised the Saudi Arabian government on the development of a nuclear energy program. We ran the RFP, the request for proposal, and also the engineering, procurement, construction, contract operations for the government of Saudi Arabia. In that capacity, I also advised the government of Saudi Arabia on bilateral treaty negotiations where the United States government was the counterparty. I've had a number of high-level representations for companies around the world in nuclear space. For example, I represented Mitsubishi Heavy Industries in a $7.2 billion litigation related to the San Onofre nuclear power generating facility in California, which was was and continues to be the largest suit in global nuclear history, exceeding even TEPCO in Japan. And have done a bunch of other interesting things in nuclear energy regulatory law. UltraSafe Nuclear was a client of mine dating back to 2015. At that time, I assisted USNC on a variety of corporate work related to its business and also on international transaction work. So national security work, export controls, trade sanctions, and things like that. When the CEO asked me to join the company about 2 years ago, I jumped at the opportunity to do that. In doing that, I've moved from a pure legal role, which is what I had done for the prior 14 years or so as outside counsel to USNC and other companies in the nuclear space, to the executive team where I sit now, helping to drive the business forward in a risk-informed way. At present, I am the Executive Vice President of Global Strategy, and I'm responsible for the global deployment of the MicroModular Reactor around the world, including in the United States. So we focus at present in the United States, Eastern Europe, UK, and Southeast Asia at present, to include but not limited to the Philippines. And it's in that capacity that I've gotten to meet with President Marcos and others in the Philippines, and it has been a wonderful experience so far. I look forward to presenting MMR to this group today and to answer questions as you might find appropriate. To the second point, so first of all, I've never said that many words about myself ever, probably in total. So if it came off unrehearsed, it certainly was. Happy to answer questions though. From the perspective of what can this group do to assist in the deployment of MMRs in the Philippines and maybe in Southeast Asia more broadly, I think there are a few things. The first, I think, has to do with education. It's very easy for me with a background in nuclear and in engineering and in nuclear physics and in nuclear engineering and the economics of global deployments of nuclear power plants and the law and such, to have a very positive view about nuclear power, about the safe uses of nuclear power, the safety of the fuel, the business model, and the rest. But I come by that having done it for more than 20 years exclusively. And I suspect that there are a number of people in the Philippines and indeed key stakeholders who would benefit from some education and some training on these topics, many of which I'll address today. But so to the extent that this group would be willing to evangelize, both for nuclear writ large, to include, BNPP restoration or pressurized water reactors, high temperature gas, or what have you. I think that that type of domestic evangelism would go a long way. Whether or not USNC ultimately deploys reactors in the Philippines, or whether a competitor does, or whether the government decides to restart Bataan or what have you. My opinion is that evangelizing for the safety and the economic benefits of nuclear and the way that nuclear can contribute to ending poverty and indeed improving the quality of life around the world would be of great value. And it's also a good story because, as it happens, it's a very honest story. It happens to be true. So, it's always good to tell true, good news stories. Those are the easiest ones to tell. There's no real downside to this story. So that's the first thing. To the point about connections, and I'll touch on the economics of this at some point. Historically, small and middle-sized banks around the world have been reluctant to finance nuclear power and the associated works, not just the construction of the generating facilities or the transmission or workforce training or what have you, but the whole panoply. The reason for that is really twofold. One, bankers are inherently risk-averse people, and banks are inherently risk-averse. That's the first thing. The second thing is, in order to sort of stem that risk aversion, banks and bankers would need to really do a lot of work to understand the nuclear business, the safety and the economics and the deployment schedule. And my opinion is that there are very few bankers who actually want to do that, against the backdrop of risk aversion. They're sort of just not willing to put in the work to understand. And it's just easier for them, quite frankly, to build a solar farm and to finance, a geothermal project. But the downside to that is, solar is not going to get the world past the climate crisis. Solar is not going to power the small farms in the Philippines. Wind and solar cannot even will contribute to grid unreliability, around the world and in the Philippines. And so it's a long way of saying that as a part of this evangelism and this outreach, I think that there's a good opportunity to work with financiers who have traditionally eschewed nuclear investment to help them understand that at least in the context of MicroModular Reactor, which is our reactor, a lot of the reasons that they had wanted to stay away and indeed have stayed away for the last 30 or 40 years aren't real. They're not real reasons anymore, owing to the fact that our power plant is inherently safe. It can't melt. The fuel can't melt. A dose to the public can't occur, which means they're not risking, high liability, low risk, but also high risk liability. And I'll talk a little bit about that. But I think that's really I think that's a key aspect to the commercialization of and deployment of microreactors, our microreactor or others in the Philippines, is getting more financiers and stakeholders to understand the risk, understand the risk and the economics and the reward. And I think that if they actually put forth the effort to do that, they'll very quickly come to appreciate that they can do very well in financing cutting edge generation for nuclear power. And I'd be happy to talk about that, later if you'd find that helpful. As to my contact information, I can be reached at my email address, which is r.backhaus@usnc.com. That'll appear on the final slide of this presentation if I rattled it off too quickly. And also my office number, which is +1 410-703-3172. And that too is on the final slide of this presentation. So we have a full team that supports the global strategy element of our company. A very bright woman by the name of Rosemary Yeremian is the lead for our projects in the Philippines, and indeed the lead for our projects in Southeast Asia. She is a wonderful resource. She knows the Philippines through and through, and she speaks very well and eloquently about the technology and about the use cases and the deployment timelines and the economics and such. So, it's not just me. I'm supported by Rosemary and 5 or 6 other folks in the global strategy team, all of whom have good familiarity with the Philippines and MMR. So maybe I'll pause there. If your team has any questions, I'm happy to answer. Alternatively, I'm happy to just spend a couple minutes talking about the company and the technology, maybe use that as a way to engender some questions.
Well, first of all, we appreciate this background, and it's fantastic we have this great link with your grandfather. Up to you. Well, Mr. President, perhaps you can proceed with explaining the company and technology, then open the question up to our inquiries. Is that okay, Mr. President?
Yeah, let's proceed with your presentation first, and then we can open the floor.
Okay, so I believe I'm sharing.
Yes.
Yep, you're good.
Okay. Excellent. So I won't spend any more minutes talking about myself, but you can see a nice title, a nice slide there of various use cases of the micromodular reactor. And just to situate some of my coming remarks, let me spend just a minute talking about what you see in this slide. Admittedly, this is a snow-covered deployment, but the punchline is that the deployment of micromodular reactor is entirely ambivalent and agnostic to the area in which we will deploy micromodular reactor. We don't particularly care whether it's hot or it's cold or it's wet or it's dry. Micromodular reactor, as you see, is deployed sub-grade. The cavity that you see there in that picture is roughly 18 meters deep. The reactor itself is about 10 meters tall. And you can see the extra concrete case. That concrete case is structural only. It doesn't serve as a containment barrier for the reactor. It allows us to connect the reactor and the reactor support equipment to stable concrete, which itself is connected to stable rock. There are some advantages to having the reactor underground, for example. The Philippines is not immune to tsunami and typhoon and earthquake and the rest. And the reactor is built to withstand those activities by being subgrade and by being in that concrete containment that we call the citadel. You'll also notice that the above grade portion of the micromodular reactor is pretty nondescript. It's just a shell. It's just a shell. It has a concrete floor, and there's some offices in there and maybe a bathroom. All of the engineering for the reactor happens below grade, and I'll talk about that in a minute. At right, you can see the micromodular reactor site, and what you'll see there is just Connex containers. The full reactor, the primary, what I'll call the primary plant of the reactor, is constructed in our facility in Gadsden, Alabama. It's assembled, it's tested, it's disassembled, and it's modularized. And when we modularize that reactor, we put the reactor in 13 Connex containers. Those are those ISO containers you see there at right. And we ship those reactors to the site for final assembly at the site and fueling and operation. And so at the right there, that's what you see. You see assemblies in those Connex containers that are waiting to be assembled. And I use that to introduce some of the coming slides. I've had the good fortune to spend a lot of time in the Philippines, the northern Philippines, mid-Philippines, and a little bit in southern Philippines. And it occurs to me that for a number of reasons, the Philippines is facing seemingly opposing challenges of enhancing economic development, which is certainly of interest to this group, and also reducing emissions in a way that addresses the climate crisis. And these are two things which are of a special import to many in the Philippines. And the key takeaway here is that the micromodular reactor, which is our microreactor, can serve to respond to both of those, both the need to foment and foster economic development, all while not contributing to the climate crisis. As you might know, nuclear power is carbon-free. It has the lowest carbon footprint of any renewable, including wind and solar, on a life cycle basis perspective. And I'll tell you that we can build 4 micromodular reactors and all the supporting equipment on 2 hectares of land. So if you think about an energy density perspective, and you compare a micromodular reactor to solar, for example, it's not close. It's not close. It's about 1 megawatt per hectare in solar space, and we would be running about 60 megawatts per hectare for MMR. So if you think about an energy density perspective, MMR is roughly 60 times more energy dense than is solar. And it's important because the Philippines has a limited amount of arable land for farming. And so if the Philippines decides that, setting aside the grid reliability issues, which would be catastrophic, if the Philippines decides to build exorbitant amounts of solar, not only will you have grid reliability problems, but you'll have plastered your landscape with solar panels, and then you have an increasing set of problems. So that's what USNC does. USNC, Ultra Safe Nuclear, designs and develops micromodular reactors and all the support equipment to make reliable zero carbon energy anywhere. And the thing is anywhere. It's anywhere that I can ship ISO containers, we can build a reactor. And you might not be familiar with the size of the Bataan nuclear power plant, for example, or the size of existing large pressurized water reactors. But punchline, they can't be built anywhere because they're just too big. The forgings are too big. You can't make the roads stable enough to support the shipping of those large components. Many of those large components require deep draft harbors, which again adds to the life cycle cost of the plant. Because USNC manufactures micro reactors, we don't have those problems. We can actually site our generating facilities anywhere or nearly anywhere. USNC is a true global company. We're based in Seattle, Washington, in the northwest of the United States. We have offices both in the United States and abroad. You can see there we have offices and engineers in Manchester in the UK, in Paris in France, Pretoria, South Africa, other places. We have a team on the ground in Manila helping us coordinate with the government and evangelize nuclear technology in the Philippines. We have two important facilities, engineering facilities in the United States. First, like I mentioned, we have our reactor factory, which is being constructed now in Gadsden, Alabama, in the southeast of the United States. You can see the yellow circle on your map there, just north of Florida. And you can see our fuel factory in Richland, Washington, again, northwest of the United States. At the reactor assembly facility I talked about a moment ago, that's where we will assemble, test, disassemble, and modularize the reactors before shipping to the site. And our fuel facility is using an existing licensed facility operated by our partner Framatome, which is a large fuel manufacturer based in Paris, as it happens. In their facility in Richland, we formed a joint venture with Framatome that will manufacture the fuel for our micromodular reactor, and indeed fuel for many of our competitors as well, if they can ever sell their power plants. Zing. So let me tell you a little bit about the micromodular reactor itself. And micromodular reactor, it is what you see there at right. The larger of the two vessels is the reactor. The smaller of the two vessels is a heat exchanger. The reactor, I'll scroll down just for a minute for effect. You can see the large vessel there at left, and you can see the heat exchanger there at the right. That reactor is a helium-cooled reactor. So we have graphite block inside that helium-cooled reactor. The fuel is inside the graphite block. The helium flows upward through the fuel, gets hot, flows downward along that internal shell. That hot helium flows out the bottom of the reactor through that two-way piping and goes into the heat exchanger, where it transfers the heat from the helium into molten salt. That molten salt is then pumped out of that helium to molten salt heat exchanger for storage in molten salt reservoirs, which are outside of the Citadel building. And I'll show you a rendering of those molten salt too. So what you'll notice is it's a very simple system. Indeed, the reactor has only one moving part. It has what's called an impeller that cycles the helium gas through the reactor and thereby controls the reactor power. So again, we're not designing and manufacturing large, complicated plants. This is a plant with one moving part. There's only one thing that can go wrong. The reactor is a 45 megawatt thermal design, which means it can make 45 million watts of thermal heat. When coupled with a power conversion system, it can make 3.3 to 15 megawatts electric with a conventional system, sort of an easy, inexpensive system. With some advantages to those systems today, we expect that power conversion can get up to 20, 18, 19, 20, 21 megawatts electric out of that same 45 megawatts thermal. And really the way to think about the micromodular reactor is that it's a battery. It's a subgrade nuclear battery. So inside that fuel is a certain amount of heat. That heat can make a certain amount of electricity or process heat or desalination. We'll talk about that in a minute. There's a certain amount of heat inside that. And it can run at full power for 3 years. It can run at half power for 6 years. If you put in, anyway, you get the point. It's just a battery. And the rate at which the user removes the heat depends on how long the battery can last and some other things, just like your children's toys. A couple of things. The micromodular reactor is safe, and I'll explain why it's safe on the next slide. But when I say it's safe, I mean that as an engineer would say it's safe, not as someone else might say. The reason I can say that is because the fuel cannot melt. The fuel can't degrade. When you hear about Fukushima, or you hear about 3 Mile Island or Chernobyl, or just the general risk of nuclear problems, what people are really talking about is the fact that the fuel can degrade. Basically, the fuel gets so hot that the fuel can crack. And in the case of Chernobyl, the fuel can explode and, bad stuff happens. Our fuel can't crack, degrade, melt, what have you. The reason is twofold. One, we have a novel type of fuel, which is wrapped in ceramic, and we take those ceramic particles and wrap those in silicon carbide. Silicon carbide is the hardest known man-made substance. At present, it's nearly as hard as diamond. The only thing that can cut silicon carbide is diamond. And I'll explain that in 1 minute. The takeaway is that the fuel has 1,000-degree margin to failure. So if the reactor has the worst case accident, the change in temperature goes up by 80 degrees Celsius. And on top of that, there's another 1,000-degree margin to failure, which is basically it's an engineering way of saying that the fuel can't degrade, the fuel can't melt. It's inherently safe. It's safe to people because the fuel can't crack. It's safe to the investment because the bank won't lose its investment because there's no damage. So I'll stop, and I'm happy to talk about that later if you've got questions. I touched on this a minute ago, but MMRs can be sited anywhere. These are tiny. You know, that vessel that you see there is, 11 meters tall, stem to stern. It's 33 feet, can fit inside a Conex container, 4.5 meters in diameter. It's a tiny plant. We don't rely on water. Again, it's not cooled by water. It's helium cooled, and that heat is passed to molten salt, 2 closed loops. It's seismically resilient because of the way that we've designed it. Also, it's subgrade, which helps with seismicity. It's subgrade. We're not concerned about tsunamis or typhoons or anything. MMR can produce both power and heat. In the agribusiness space, as you well know, heat is a large component of cost, and it's a necessary function. Food processing plants use heat and power, and the MMR can provide heat at 560 degrees Celsius and a whole lot of electricity for an extended period of time. Also important, and owing to the fact that this is a nuclear battery, the reactor can go up and down in power, day to day, week to week, month to month, season to season. Traditionally, nuclear has not been able to do that, but our design, because it's a high temperature gas reactor, can do that. What that means is that for a customer or a partner that wants to site a micromodular reactor for a facility, may need 5 megawatts electric of power. But let's say in 3 years, that company is doing so well that now it needs 15 megawatts electric. That company doesn't need to go buy a new generating asset. All I need to do is turn that impeller a little bit faster to move the helium a little bit more quickly through the core, and that can bring the core power up to 15 megawatts electric. Also, if the size of the plant goes down, and I'm using an agribusiness example here, from full capacity to half capacity, we can turn down the power on the reactor. And if I turn the power down by half, the battery will last twice as long. So again, you can see how the economics of this nuclear battery foster widespread deployment in ways that nuclear has not historically been able to do. And I talked about the last thing a minute ago, which is that, the second to last thing a minute ago, which is that our on-site construction time is 8 months, maybe 6 to 8 months. We have to collect about 2 years of data, site data, seismic data, wind, geology, surface water, stuff like that. But the site construction is 6 to 8 months. So it's actually faster than siting a gas power generating facility on a site. And lastly, our reactor can harmonize with renewables. It's actually the biggest thing about the molten salt tank, because again, we're putting the heat in the molten salt reservoir. And when the sun is shining and the wind is blowing, a plant can use that cheap electricity. But when the sun is out and the wind stops blowing, the reactor can come online quickly and fill that gap. So what that lets you do is it lets you rely on low cost electricity, pure renewable electricity. And then when that pure renewable electricity is not available, MMR can come online and provide continuity of power, which is important for facilities that need to run 24/7, 365. And our safety starts with our fuel. This is a little bit engineering, but at left, you can see a triso particle. And what you see there is cutting edge breakthrough in nuclear fuel developed by the national labs in the United States and perfected over the last 50 or 60 years. What you see there is a uranium kernel. That uranium kernel is about 1/2 of 1 millimeter in diameter. We manufacture our own triso. We're the only entity, private or public, outside of China that presently manufactures triso. We wrap that uranium-235 pellet in 4 layers of ceramic, which you can see there. It doubles the diameter from about 1/2 millimeter to 1 full millimeter of diameter. And then we take about 10,000 of those little particles, load them into that shell that you see there in the middle of your screen, entitled FCM fuel pellet. Just pour them in. We have a process that makes that shell solid. And then we take those fuel pellets and add them to that graphite block that's there at right. You can sort of see in small way the cylindrical pellet sliding down into the cylindrical hole to form a fully loaded graphite block. Then we take those graphite blocks, stack 280 of them inside a core. I'm not sure if you can see my mouse here, but you can see those are 280 graphite blocks, each loaded with fuel. And then that is the core of the reactor. And I say that again, because that is USNC's differentiator, is the fact that the fuel can't melt. TRISO is inherently robust. U.S. Department of Energy has said that it's the most robust nuclear fuel on Earth. And then we go one step farther. We then take that most robust nuclear fuel and add it into silicon carbide pellets, which we also manufacture, adding another barrier to fission product release. And between those two barriers, we're comfortable saying that there's negligible risk related to a nuclear incident. Here you can kind of see 2 micromodular reactor power plants. One is the nuclear portion is at left there. It's the 2 yellow buildings. And at right, you see the balance of plant. So you have the nuclear piece at the left and the non-nuclear piece at the right. They're separated by the molten salt storage tanks. For manufacturing electricity, one would want to take the heat from the molten salt storage tank, pass that through a heat exchanger that takes the heat and passes it to water to manufacture steam. Then the steam goes through the turbine, spins the turbine, and that's what makes electricity. So what you see there is a very small footprint. That's less than 1 hectare of land together. If a partner needs to have 60 megawatts electric, for example, and does not want redundancy, that's 4 MMRs with the balance of plant, 4 micromodular reactors with the balance of plant. If the need increases thereafter, after initial siting and operation, we can come in and add nuclear batteries in series right on top. If, like I said a minute ago, demand goes down, all we need to do is decrease the helium flow rate through the core, and that lengthens the amount of time the battery will last. We have a number of projects around the world, most of which I can't talk about, some of which I can talk about. We have projects in Canada at present, undergoing licensing by the Canadian Nuclear Regulator. We have a second project in the United States being licensed by the NRC, US NRC. When we have several other projects too. McMaster University in Canada. We have a project at Lappeenranta University in Finland, and a project in Police, Poland, with West Pomeranian University of Technology in Szczecin, supported by Grupa Azoty, which is a large fertilizer and agribusiness company located in Poland, and many, many other projects too. Too many to fit the slide. Importantly here, though, each of these projects serve a different purpose. They're each demonstrating a different purpose, which is important as USNC prepares for global rollout of the MMR. So let me talk a little bit about the benefits of MMR to the Philippines, and then I'm happy to answer whatever questions this group may have. You know, agribusiness and the food processing industries are one of the largest and most important industries in the Philippines. Those businesses provide jobs and livelihood, use of land, and indeed they're economic motivators, not only for the people who are employed by these companies doing these things, but also all of the ancillary business, as you well know. One of the key challenges facing agribusiness and food processing at present is the lack of adequate infrastructure. And now I'm talking about electricity infrastructure, grid scale infrastructure, and the lack of reliable generating ability. I spend quite a bit of time talking with Meralco. I understand Meralco's limitations quite well in transmission and distribution space. And, they're working to fix those problems. One of the nice things about MicroModular Reactor in that regard is that that reactor does not rely on transmission. Typically, you have generation, and then the electricity goes out of the generator into transmission lines at very high voltages, and then goes through a step-down transformer to distribution lines, and then is used by the end user. Because MicroModular Reactor can be sited right with the user on the user's land or adjacent to the land and not 100 kilometers away, we avoid a lot of those transmission and distribution related costs and can provide nearly 100% power over extended periods of time to allow the economic expansion that the industry so desperately needs. The other thing is these businesses require a lot of water. A side benefit of MicroModular Reactor is that we can use waste heat to do desalination. So basically, the way that would work from an engineering perspective is that the reactor would manufacture the heat would be converted to steam, the steam would turn the turbine, making carbon-free, high-quality electricity. There's still a lot of energy left in that steam, though, after it exits the turbine. And we can use that, we call it waste steam, to do thermal desalination and provide clean water as an extra revenue stream, basically as a free revenue stream to the production of electricity. And I suspect that water and the abundance of that water and the quality of that water would be of great interest to folks in agribusiness and food processing. And again, it's free because we're just using waste heat to do desalination, to make drinking water. I touched on these a minute ago. MMR is always on, it's safe, it's carbon free. Because they're small, we can site these reactors behind the fence or immediately adjacent to existing facilities. I talked about waste heat to desal. I talked about the fact that the reactor can, because we have the molten salt storage tank, which separates the primary plant from the secondary plant, pair perfectly with renewables. Again, when the sun is shining and the wind is blowing, partners should use that electricity. It's cheap, it's cheaper. But when those sources are not available, then MMR comes online to pick up the trough. So we believe that the MMR is perfect for many, many Filipino markets. And indeed, we've had very strong reception to deploying MMRs in the Philippines. We've talked with a variety of people in the legislature. I've had meetings with President Marcos, who's a strong proponent of our technology and the deployment of the technology in the Philippines. Folks in the executive branch, Department of Energy, Philippines Nuclear Research Institute, and others. For all these reasons, right? It's safe, it's small, it's cost competitive. We can lower the cost of electricity in a wide variety of Filipino applications. It promotes grid resiliency and grid stability, inherently safe, and it can integrate well with renewables, like I said a minute ago. We have developed a pretty good path forward for partners who are interested in learning more about the micromodular reactor and USNC. We develop bespoke products. We're now working on a feasibility study for deployment of micromodular reactor for Meralco. There are others in the Philippines that we are preparing to embark on these types of studies. These types of studies cover a number of things, use cases, market overview, an overview of the technology itself, how it is that the micromodular reactor would integrate or not with existing generating facilities of a partner. We talk about licensing. What does licensing of an MMR actually look like in the Philippines? And then, of course, the socioeconomic impacts and the financial costs associated with that. The pre-feasibility study is sort of a red light review. It's a screening review. It helps winnow sites to make sure that the sites that are being evaluated are the ones that are ultimately good for construction. And that full feasibility study is the same type of thing, but more detail and with fewer sites typically, although there's no reason why we couldn't do a full feasibility study on multiple sites. Just from an economic perspective, it often makes sense to do that screening review first, and on those sites that rise to the top, do the full feasibility study there. So I know I said a lot of things. I'm happy to take questions if you think appropriate.
Mr. President, if you don't mind, I usually ask at the very end, but I like to ask this upfront already because we're an agribusiness group. Apparently, Roland is very well connected. We cannot help him with connections, except maybe going to the smaller agribusiness enterprises where we could do what he says, evangelize, etc. Very quick question, Roland. First of all, of course, there are many projects depending on the project. What would be a minimum project cost size, and what would be the typical return on investment? Yeah, so we just want to know where we can market this thing. What's the minimum project size? What's the general? Of course, it depends, but what's the general return on investment?
So let me address the question from a couple of different angles, because it's important how we think about the deployment of MMR there. Historically, big generating facilities, nuclear or otherwise, basically just come in and they plop down a plant and they say, here's your plant. This is the cost of the plant. This is the cost of your OpEx of the plant. This is the cost of long-term licensing, and this is the cost of maintenance and such. And then the nice thing about that is it allows them to know pretty easily what the cost will be from a levelized cost of electricity perspective, or from a levelized cost of heat perspective. The downside, of course, is that if you don't need that product, like a large power reactor or a coal plant or what have you, they can't tailor that product for a partner's need, for a customer's need. It's sort of one-stop shopping. It's the only thing they offer. And I say that because the economics of the micromodular reactor, and indeed MMR deployments, which is really the crux of your question, really has to do with a particular partner's need, and importantly, when their need occurs. So let me say a couple things about that. The first thing that drives the economics of MMR deployment is the schedule. It's when a partner wants to have electrons on the grid or heat from the reactor. And the reason is pretty simple, and it owes to the factory construction that I talked about. Our reactor factory is going to produce MMRs beginning in 2027. The first MMR will come off the assembly line Q1 2028. That reactor will be the most expensive reactor we produce, just like the most expensive Model T or Model A or Tesla or Airbus or whatever else. It's the first one is the most expensive. But also as we come down the learning curve, and as we get better at manufacturing reactors, and as we get better at shipping, and as we refine those processes, the costs come down precipitously, to the point that after 4 or 5 years of manufacturing these reactors, we expect that our costs will come down just on this metric by about a third, maybe 30%, just on time. So it's a long way of saying that if there's a need for power in 2028, that reactor is going to be more expensive than if that same need exists in 2032, because we're going to manufacture roughly 10 reactors per year per reactor assembly facility per factory. So that's the first thing that I will tell you. And the difference is about a third. The second cost driver also has to do with the number of reactors that a particular partner will want to order, and whether those reactors will exist at one site or multiple sites. And the reason has to do with the costs of engineering, procurement, and construction of those plants. So the punchline is that a 4-unit plant is the most economic plant for us and for our partner at one site. And the reason is there are a lot of efficiencies that we can take advantage of and the partner can take advantage of by siting 4 reactors at one particular site. The same as it happens, the same number of people are required to operate 2 reactors as are required to operate 4 reactors. So if you think about, for example, so if you think about an OpEx piece of this, there's added value to just having those extra 2 reactors. In order to do a detailed discussion about pricing, we would need to understand at least those 2 pieces, at least the when do you need electrons or when do you need heat, and what does an order actually look like for you? And is that 1 site, 2 sites? Was it 1 reactor at 5 sites? And that's really the goal of that pre-feasibility study I talked about, is it lets our engineers and our siting engineers work with partners to understand what their needs are and when they occur. One of the outputs of that pre-feasibility study is the economics of a micromodular reactor deployment, including but not limited to levelized cost of electricity and heat. So I know I said a lot of words, but that's the right way to think about this. It has to do with when and how many reactors.
Yeah, well, okay, we understand exactly what you said. Perhaps offline we'll ask you more questions. Mr. President, that's all my question for the time being.
It is 9 o'clock. There are some questions already lined up. I'll ask for just a bit more patience from our audience. We will move into our informal Q&A session after this. So just for your, just so you know, Roland, and of course for the people who are watching online, unfortunately, this is the end of what you can see for free. So we upload all of our sessions online for free, but we don't allow people to engage with the speaker during the free sessions. After this one, we have our informal session where we open the floor for a more informal, more free-flowing discussion with the membership of the foundation. So I'm going to say a few things just to end the formal session itself, what we're going to upload online. I will say goodbye to our audience, but please don't leave yet. If you are, if you're, I hope you can stay with us for the informal session moving forward. Anyway, so okay. So first of all, I'd like to give our appreciation. Let's give our appreciation to Roland for a very, very informative and very, very detailed presentation on the potential of MMRs in the Philippines. If I got it correct, it's a micromodular reactor. Is that correct? Yeah. So I looked it up on a bit. I took a look at your website and did a bit of some checking on the information. But anyway, so the Agribusiness and Countryside Development Foundation, in partnership with the Management Association of the Philippines, together with all of our members, our special partner institutions, senior special partner institutions, corporate members, and individual members, all present the certificate of appreciation to Roland Backhaus for his invaluable support in the advocacy and promotion of agribusiness and countryside development, and for his commendable and unselfish services rendered to this foundation as our resource speaker, given on our 47th weekly online meeting of 2023, this 12th day, although in your case, I think it's still the 11th, in Makati City, Philippines. Signed Ernie Ordonez as our chairman and myself as our president. And I'd like to invite everyone now to please turn on your cameras for a group photo for documentation purposes to show that we are actually, using our money properly for these sessions. Yes, so big smiles, everyone. Hope we can see everyone online. Ramon, Richie, yeah. Okay, so Vivian, can you count us in for the group photo, please?
All right, sir. At the count of 3, smile. 1, 2, 3, smile. Thank you very much po.
Okay, thank you very much. And for those of you who do have to go ahead, thank you very much for joining us. But before you do we have a session for next week already, Bernie?
We have a break because it's Christmas, so we will resume in January with a person, our speaker coming from the World Food Program, who will present the livelihood map of the different municipalities of the Philippines. Thank you.
Thank you so much. So sorry, I made a mistake earlier. I thought this was the penultimate. This is the ultimate session for 2023, and we'll actually be seeing you in 3 weeks in the new year. Is that correct? That's January 2. Is that correct, Bernie, or is it January 9?
9.
Sorry, January 9.
9.
So fun. We'll see you in a month and year with the World Food Program. Thank you very much for your tireless work, Bernie, in finding our speakers from all over the world to help us see which opportunities we can find for poverty alleviation here in the Philippines. Okay. So with that, I'd like to thank everyone who's joining us this morning, and for those of you who are joining us online, again, I'm so sorry. This is the limit of what you can access for free. If you are interested in joining us for our informal sessions where we can have a freer discussion with our speakers, especially with such an interesting topic as what we have today, or engage with our wide network of agribusiness and countryside professionals and organizations here in the Philippines, please do consider joining us as a member. The AgriBusiness and Countryside Development Foundation is in partnership with the Management Association of the Philippines, and we are a nonprofit member-supported foundation. It's only through your generosity and support that we can continue to bring you these opportunities for education on what opportunities exist for poverty alleviation in the Philippines. If this interests you in any way, please do consider joining us as a member. Our links are in the description. You can send us an email, introduce yourself, and we'd be very happy to have you on board. But with that, again, as I've mentioned, I have to end the formal session. For those of you who can stay for the informal session, please stay on. But for the rest of you, we'll see you next year. Merry Christmas and have a happy New Year. Bye-bye.